Welcome to the webinar training series for the Equals Math curriculum. My name is Jennifer Emanuel, and I will be your trainer today. In this webinar, participants will be provided with information regarding the Solve poster for the Equals Math curriculum. Let's get started. This is a very basic slide for what I consider to be a very complicated process. But when I really stop and think about my journey with the Equals Math curriculum and what I know about training the curriculum for the past 7 years, it's really important to think about implementing Equals Math as a journey. The first 1 to 5 months are by far the hardest climb in this entire journey. It's important to acknowledge everything that you have accomplished up until this point. You've become familiar with the materials. You've organized and placed the materials in a space in your classroom to support your instruction. You've assessed and placed your students. This next phase that you're embarking on is really the turning point. Lesson instruction takes place over the course of several months, and it's for a reason. The lessons are layered with support. When I first began teaching Equals Math lessons, I was a brand new special educator. I honestly felt very unsure and was constantly wondering if what I was doing in the lessons, if I was doing that justice. I was wondering if I was differentiating correctly for my students. But every day at the school where I taught, we had a dedicated math block that we were to teach the Equals Math curriculum. I found that over time, and as I became more familiar with each lesson and the lesson philosophy, the easier it was for me to differentiate effectively for my students. But that took several lessons for me to learn. As your comfort with the curriculum increases, you'll move on to these phases of reflection, understanding, and ownership. After a few lessons, you might find yourself reflecting back on the activities, how your students were understanding the objective, how they were engaging with the materials. You might find yourself asking, why are we using this material? Do I need to adapt any of these activities or action words to support my students' engagement? Can I collaborate with any of the other individuals in my school? So do I need to collaborate with my speech and language pathologist? Do I need to work with my OT or PT to support engagement? As you move on to understanding, this occurs when you begin to see the purpose of different activities in the materials, and then you confidently begin to adapt those materials almost naturally within your lesson. And then finally, ownership. Ownership occurs when you begin to make equals your own. This is when you find your confidence with the lessons. For me personally, I not only found myself more confident with the lessons, but I also found myself as more confident as a math teacher. This really allowed me to differentiate and use the materials within the lesson and in the curriculum in a way that more suited my teaching style. An example of ownership is shown here. In the picture on the left, the teacher is using her smartboard to display a digital solve poster from the members only content. She did this to support her students' engagement as well as her own teaching style. So this is an example of how she owned this activity and adjusted it to fit her specific classroom need. On the right, this teacher recognized that her students connected with the manipulatives during the lesson. To complete her solve poster, she traced the objects they were using to represent student thinking while solving problems. The key takeaway here is to know that your teaching style and what you know about your students should absolutely be present within your Equals Math lessons. So with all of this in mind, and as we move forward, the focus of our webinar today is problem solving. When we really stop and think about using math from a functional point of view, problem solving becomes an important tool for students to utilize the concepts they are learning from that real world perspective. It is for that reason you will see Equals lessons focusing on developing a student's problem solving skills. When we really stop and think about how we problem solve in our daily lives, when we're faced with a problem, we go through steps similar to the ones that you see on our solve poster here. Now, it might not be in the exact order that you see here, but for the most part, when we're faced with a problem, we identify the facts. We think about the action that we need to take. We estimate what our solution might be. We think about what strategy we can use to solve the problem. It's for that reason you will see multiple opportunities to support students going through this problem-solving process in every lesson so that it too becomes a more ingrained part of their lives. We all know that out in the real world, students are not always given that exact word to take to solve a problem. They're not always provided that structure of a worksheet to work from to solve a problem. It's the conceptual understanding of the concepts they are taught during math, coupled with the problem-solving process, that makes it a natural part of their thinking. This allows for the math concepts being taught to be used as a tool for problem solving. Asking students to use the skills they are learning from a problem-solving point of view allows students to move beyond just a rote skill understanding and gives students an opportunity to increase the functionality of all math skills within their everyday life. Now, with the philosophy in mind, it is important to recognize some important considerations as you get started. And these are ones that you really want to keep in mind as you begin to teach the equals math lessons. As you begin to teach the problem-solving process with your students, recognize that this is a brand new process. Students will absolutely need support to complete each step, and that should be expected. Remember that this process feels innate to us because we have years of experience. For students with significant disabilities, their experiences with problem solving has looked very different. During problem solving activities, it is important to think of it less as getting the right answer all of the time and more about experiencing each step. When I was at an NCTM conference, I heard a presenter say that our focus oftentimes in math is all about getting that answer quickly. And that's actually doing our students a disservice. We really need to acknowledge the importance of getting students an opportunity to experience going through these problem-solving steps, choosing a tool, working with that tool to solve a problem so that it can become a more natural part of their learning and of their life. Keep in mind that we view math from an experience lens. This is one I had to constantly remind myself of. But when a student shows misunderstanding or struggles with a meaning of a particular vocabulary word or an action word, consider the very beginning or basic knowledge that might be missing. For some students, and actually many students, it's oftentimes the language. As you begin to view the problems, think about what is being asked and then use what is provided in the kit to represent the language. For example, the action cards, the vocabulary cards, concrete connections, those can all be used to represent the meaning of the words that students may not know. If needed, take the time to explicitly model the action words with the tools. If a student is showing misunderstanding or a gap in their learning, it's okay to stop and demonstrate. As we know, this is an important part of that learning process. We would never expect a student to know something that they have never been taught before. So this should absolutely apply to the tools and the actions that are found in the lesson. Finally, the problem-solving activities are there to provide an opportunity to explore, think, and act. It would be expected that students will be supported during this time with choices and actual objects to make it meaningful. Use the differentiation supports that are embedded in the curriculum to make this a meaningful time for all your students. For students with significant disabilities, it is important to consider the purpose of the problem-solving process. The purpose is to show students how we naturally solve problems. Problem solving provides time to strengthen understanding, language, and thinking. We are teaching students to stop, think, and make choices to solve a problem. Remember, this takes time, and you will need to be very explicit in each step. Now, to support students with significant disabilities while problem solving, support the steps on the solve poster with concrete objects. So when you begin to look at the solve poster, know that you can absolutely represent each step of the solve poster with concrete objects to reinforce understanding. When teaching this activity, look to the items within your kit and classroom to support the facts of the problem. Incorporate the vocabulary cards, the action cards, the pick symbols, as well as manipulatives to provide that tangible connection to the abstract steps of the problem-solving process. Another tip would be to take the problem-solving activities as an opportunity to model each step to show students how an experienced math learner thinks and solves a problem. As a reminder, these problem-solving activities on the second page are meant to be experienced by students. It is not necessary to make it about data collection. Provide time for your model as well as students' engagement during this activity. In most lessons, there is generally a more concrete strategy than one that is more semi-concrete or abstract. You might find it most helpful to select the strategy that is more concrete for some of your students. As you complete the strategy with your students, you may absolutely support them as they need when engaging with the tools or the materials that are out. Observe your students during the first page of the lesson, engaging with the materials, and identify if there are materials or action words that they might need more support with. You may ask yourself, are there additional adaptations that I need to include so that this student is successful? Utilize the action dictionary to provide some possible adaptations that might be most successful with your student. To support a student's understanding of each step of the problem-solving process, choices can be used as a meaningful tool. As you demonstrate each step of the problem-solving process, provide choices of the facts, actions, strategies, even estimates, so that students can begin to develop a meaning of each step of the solve poster. These choices can be provided in a field of 2, with one choice being an obvious distractor. But what is important is that you can reinforce that choice by showing how it relates to that problem-solving process. Finally, when working with students with significant needs, it is important to acknowledge and discuss those cause and effect relationships. By modeling and providing hands-on experiences with math tools and actions, students have firsthand views of cause and effect. When students are familiar with an action and its effect, they are more likely to choose that action when it makes sense in solving a particular problem. On the previous slides, I went through some very general tips to support students with significant needs. It is important to know that we have a specific training geared for those students who may need some additional support during the lesson. If you are interested and want to dive deeper into supporting students with significant needs, you can head out to our Equals Math YouTube training channel and look for our instruction and supports for students at levels 1 and 2. That will go in farther into the tips that I provided on the previous slides there, and we'll really go through how to support your students who have significant needs during your Equals Math lessons. Now for the training today, the lesson that we will be using is 4A3. So it's chapter 4, section A, lesson 3. The lesson objective is join result unknown problem types, sums to 10. In these activities, students see how they can count and represent sets using the stacked number line. They learn how they can count on with the math line by sliding tabs to the side. In the previous lesson, as well as including this one, students have also been shown how to add using WorkMat 35. So let's take a look at what all of this looks like when we're supporting students while problem solving with this lesson objective. It's important to acknowledge the progression of learning that occurs during the lesson. As a reminder, when teaching equals lessons, you do want to make sure you teach the lesson activities in order. On the first page of the lesson, all of the activities present are leading up to the problem solving that occurs on the second page. On the first page, you are introducing and modeling the actions and reinforcing them with the action cards and tools. The math tools that are used during the problem solving component or activity are introduced and modeled on this page so that students can become familiar with them. The first page is really that important part of the progression of learning that's present within the lesson. On the second page, students are asked, what tool should we use? What action can we take? The activities from this first page are the foundation for students to pull from to make that connection and to answer those questions. I'm going to briefly go over the activities on page 1 for this lesson, just so you have a context of how these lesson activities relate to the problem solving on the second page. So beginning on the first page here with Math Dash. During Math Dash, the action cards are introduced. And during this particular activity, we're using WorkMap 35 as a review opportunity to give students that chance to activate their prior knowledge about using this tool to count and add amounts to 5. So this activity is directly relating to our lesson objective, and we're providing students with an opportunity to review a familiar tool and now to connect it to the lesson objective that they're working on. In every lesson, a theme is used to support students in recognizing where we may find this lesson objective within a real life theme. In this particular lesson, the working at the pet store poster is used as our theme. We can discuss how we might use this objective within this theme. So we can discuss that when we go to the pet store, we use money to buy pet food. We can discuss the shape of the cans that we see on the poster, that they're cylinders, and we can use our building blocks to represent those cans of dog food that are shown. Know that the theme identified here is also used within the problems of the lesson. So consider posting your theme poster in your math area so that you can reference it again while you're problem solving. Math tools is also one of the most important activities on the first page. So this is the activity where you have the opportunity to model how to use the tools. Take your time with this activity. Make sure that you show how these action cards, count, count on, and add, can be used and are connected to each tool. Be explicit with your model. Once you have modeled each tool for your students, give your students that opportunity to try it out. Take that time to observe if there are any tools that your students are connecting with or ones that they might need additional support with. This will all help your students as they move on to the problem-solving activities on the second page. And then finally, during number notes, we ask students to show what they know about the objective. The materials that have been used up until this point are placed on the table to support your demonstration, as well as students when communicating what they know about joining sets to 10. So for example, I might demonstrate that I know I can use connecting cubes to count and add amounts. I can then place those cubes on my number notes poster to show my thinking. After I show what I know, students now have access to all of the materials out on the table to show what they know. I might have a student use WorkMat 35 to show how they know they can count sets to add. Another student might show that they can add 10 by using a math line. I might have a student who looks at the stacked number line, and I can reinforce that action by writing right on the number notes poster. We learned about new tools to add on the number line. This activity really is giving students an opportunity to connect what they have learned throughout the first page to language and action. With all of this in mind, we're going to move on to the second page now and begin to look at the problem-solving activity. Before beginning the problem-solving activity, it is important to really just become familiar with the layout. When we look at the top line, notice that our 3 action cards that we used from the first page, they are present here. So these 3 action cards are the same ones that we were using on the first page. When you read through the top line of the paragraph here, it will state what materials you need. So in this particular activity, I need 10 $1 money cards, work mat 35, and the math line out on the table. Finally, you can locate the strategies that you'll be using during the problem-solving activity. And think about it, they're underlined within steps 4 and 6. And then in the Solve It Together activity, they're located and labeled right in step 4. The strategies for the lesson are meant to be demonstrated to students during Think About It, and then they're meant to be provided as a choice for students to use or to choose from when identifying what strategy they want to use to solve the problem. You might find it helpful to model these strategies before beginning any problem-solving activity. So I have an example of what the strategies look like here from our YouTube training channel. Please note that not every lesson will have a video.
To solve this problem, we're going to count the amount at the start. 1, 2, 3, 4, 5. Next, we're going to count the amount in the change. 1, 2, 3. We're going to add them together in the result. Now, we're going to count the total. 1, 2, 3, 4, 5, 6, 7, 8. There are $8. For this strategy, we're going to say the first amount, $5. Then we're going to count on 6, 7, 8, 30.
Prior to completing the problem-solving activity, as I had said, you might want to model each strategy with the materials. So when the question is asked, what should we use, or what tool should we use, what strategy can we use, they have your demonstration to pull from. These strategies we introduced on page 1. So these materials should feel very familiar to students. As you start to review the materials and find yourself wondering about a particular student and what these strategies may look like for them, think about utilizing the differentiation strategies that have been discussed previously. So when looking at the action words in the strategies, notice that there are purple words. So we have count, add, say, and count on. If you find yourself wondering how your student will count with the math line, this would absolutely be the time to access the Action Dictionary for suggestions. When I look at the pages for the Action Dictionary word count, I see that there are 3 pages of suggested adaptations that I can use. So I can look through all of those adaptations and decide which one I feel would best support my student. Once I have an idea of, okay, which adaptation do I want to use, or what few adaptations that I want to try out with that student, I might find it helpful to create a mini lesson based on those adaptations to identify that specific one that best supports that student for that specific action word. As you are differentiating, it is important to keep the following tips in mind. You might find it necessary to use hand-under-hand support to complete the strategy with each student. As you're completing that support with your students, you can absolutely pair that action with the math appropriate language. So for example, as I'm supporting my student in sliding the math line tabs to the left as we count, I would say, we are counting with this tool. Each time you ask a student to complete an action, reinforce it with the successful adaptation so that over time, students can begin to develop a meaning for that action word with a consistent tool. And most importantly, know your model is important. Every time you place a math tool on the table, model how to use that tool with the successful adaptation. To pull all of this together now, we'll begin by looking at the first problem, the Think About It activity on page 2. This activity is a teacher modeling opportunity. So this is where you as the teacher are showing students how to take the tools and actions they observed on the first page and apply them to a problem-solving opportunity. It is important to remember that when you use the solve poster, to think of it less as 5 steps to memorize and more as this is how a student can learn to approach a problem. For now, teach your students, but do not expect that they will know this process right away. As with learning the lesson objectives, learning how to solve a problem takes time. It could take a year for students to feel competent with this process. So when we look at the problem for this particular lesson, the directions state to write and read the problem. When I look at the problem, it's written as Mr. Brandt works at the pet store. He scanned a bag of cat food into the cash register. The customer gave Mr. Brandt 5 $1 bills and 3 $1 bills. What is the total amount the customer gave him? Now, for the majority of my students, this problem would be too overwhelming with far too much language and unnecessary details. When you begin to view the problems, know that you can absolutely eliminate the additional language as long as you stay true to the essence of the lesson objective and math vocabulary. So how I would rewrite the problem for my students is, Mr. Brandt works at the pet store. A customer gave him 5 $1 bills and 3 $1 bills for a bag of cat food. What is the total amount the customer gave him? Now, knowing my students, I know that they'll need some additional support with the language. So I can now look to the parts of the curriculum and what I have in my classroom. So I can use the poster cards to represent the theme, pet store. I can use the $1 money cards to represent the amounts the customer gave him. I can use the internet, just a random picture from the internet to represent cat food. And then I'll use the vocabulary pick symbols for the words total and amount. As I read the problem, I can represent this information by placing these objects or pictures or images. Another example of how you might rewrite the problem or what your rewritten problem might look like is to use sentence strips and actual objects that are attached to the pocket chart here. So this is another example. It's a different problem, but it's another example of what it might look like to rewrite the problem with the materials from the kit. Another tool that you might use when you're rewriting the problem is very similar to the picture that I showed you from the ownership slide, where you might use your smartboard and the Equals Technology Lesson Center to show a digital copy of the solve poster, but then you can also use text boxes to rewrite the problem. And then you also have the large image library within the Equals Technology Lesson Center that you can use to quickly support the problem with pick symbols. So all of these are different ways that you can rewrite the problem in an effective way if needed for your students. So once I have my problem rewritten, I'll read it aloud to my students. You can also use the solve poster if you would like to really guide your thinking as you're going through this problem solving process. So I can point to the first step on the solve poster and say, okay, the first thing I need to do is identify the facts. So what do I know about the problem? Now I can show my students how I, as an experienced math learner, can use choices to identify the facts. So I can provide choices out on the table to show facts that match the problem. So once I show my choice out on the table, I can say, okay, what do I know? Well, I know that a customer gave Mr. Brandt 5 $1 bills and 3 $1 bills. I can show that those choices that I made directly match the amounts that came right from the problem. I can also show my students that we are solving a problem within the pet store. So I can bring the pet store cards right over to my solve poster. And I can say, all right, well, I know that Mr. Brandt needs to know the total. So I can pull the pick symbol for total right over to the solve poster. In doing this action, I'm showing my students that the facts that I'm pulling are pulled right from the problem and that these solve poster steps are directly related to the problem that we're solving. So it's not like these steps are coming out of thin air. They're there to support us as we go through our problem solving process. Step 2 is about identifying the action or actions that are necessary to solve the problem. This step is to help students focus on what to do. Since you have demonstrated these 3 actions on page 1, they should feel familiar to students. But if you feel like you need to re-demonstrate each action and show how that action is connected to the tool, you can absolutely take that time right now during step 2 to re-demonstrate each action with the tool. Once I've demonstrated the action, I can then say, all right, I know I need to add the money amounts. I want to know how to get the total. Step 3 is about estimating the solution. This is really there to help students understand the reasonableness of a solution. So what I always tell teachers when they're getting ready or when they're asking students to estimate or predict a solution, this is absolutely the time that we should be providing students with choices. A lot of the times when we ask students to estimate, that's a very abstract skill, especially if they haven't been exposed to estimating a solution yet. So this would absolutely be a great time to provide those choices to say, okay, well, we know that there's a pile of $5 bills and a pile of $3 bills. What do we think the solution might look like? Will it look like a set of $9 bills, $1 bills, or 2 cylinders? Now, depending on what our students choose, we're going to put that estimate up on the solve poster so that once we get down to step 5 here, we can compare our solution with the estimate. Over time, we might find that our students' reasonableness is becoming more successful when estimating and predicting, but initially these choices are really quite critical to support students in learning what it means to make a reasonable estimate or a reasonable prediction. Now, if our students choose the 2 cylinders, absolutely bring that over to the solve poster so that when we compare our solution with our estimate or prediction, we can have that thoughtful conversation about, all right, does our solution look like our estimate, or how could we have changed our estimate to make it reasonable? Step 4 is to identify the tool and strategy. I will demonstrate each strategy and tool now to the students so that they can see what I am thinking and how I decide on the tool. So I can start by saying, well, I know I can add in different ways with these tools. I know that I can add by counting on money cards from 5 using the math line. I know I can also count money cards on workmat 35. So I can show 5 in the start, 3 in the change, and then add them together to count the total. I want to count on using the math line to find the total. So I'm going to use the math line to count on 5, 6, 7, 8. I added with the math line to get my solution $8. So once the strategy is shown and demonstrated, I can then talk to my students about the solution. So my solution is $8. I counted on from 5 to add 5 and 3 more dollar bills. 5 plus 3 equals $8. I can now take that solution and compare it back to my estimate to say, okay, was our estimate close? To provide an idea of what this may look like in action, I will share my workspace to provide some tips and demonstrations when completing the problem-solving activities. So I have my workspace here, and it's important to think about when you start the problem-solving activities on page 2, that we have introduced the theme of where this problem will be solved on the first page of the lesson. It's important to really consider the pace of your equals math lesson. Typically, an equals math lesson takes anywhere from 1 week to about 2 weeks to complete. So with that in mind, you might find it helpful to your students to bring back out the theme poster and discuss again the context or the theme that is found within the lesson. So in this example here, I can show my students this theme poster and say, I have a friend, his name is Mr. Brandt. Mr. Brandt works at this pet store. A customer comes into Mr. Brandt's pet store and wants to buy something. What's something that a customer might buy? And then my students might look at the images and say, you know what, they could buy dog food. And I can say, you're right, they can buy dog food. You can also buy cat food at the pet store. Now, what I've done with this cat food object here is I've taken a building block cylinder and I've taped an image of cat food to the cylinder so that it can be a concrete representation of a can of cat food. Now, what's really important to know, and if you are interested in providing this support for students, is that we went through all of the problems within equals and provided a pick symbol for the units found within those problems. So if you wanted to provide a concrete representation such as this, or just a pick symbol representation of the units within the problems, you can locate all of these problem solving images within our members only content within the problem solving images folder. Again, this is found within the problem solving images folder. This picture of Mr. Brandt here is from the problem solving images folder. So if you feel like this is a support that you want to explore, do make sure you locate those within your members only content. So after we've really provided this context of where our problem will be solved, we can now start moving into our problem solving activity. Now, every problem solving activity is rooted in your solve poster. So when you look at the solve poster, you might decide that you're going to write on the solve poster with dry erase marker. You might decide that you'll attach particular objects or pick symbols right to the solve poster to represent your students' thinking. I had a really great teacher who I was able to observe take this one step further and show a little bit of ownership by taking her solve poster and by cutting it into individual steps. The reason why I really like this is it allows you to move these steps and adjust them for space depending on the materials that you're using. So if you're thinking about those students who primarily communicate by using those concrete objects or through that engagement and demonstration, you can take those materials that they're connecting with and place them right up on the solve poster below that particular step without covering up the rest of the solve poster itself. I also saw the same teacher take clips with magnets on them so that she could post them on her whiteboard. And again, then she could quickly just adjust her space as needed. So this is just a suggestion or a tip, but I do find it to be really quite helpful, especially if you are dealing with a lot of manipulatives that you want to post on your solve poster. If you are uncomfortable with cutting apart your solve poster from the content kit, know that there is a printable version of the solve poster available within your members only content. The first step in our problem solving process is to write and read the problem. I have seen some very successful teachers using this particular strategy for writing out the problem. So they'll use a word processing program to write out all of the problems for an entire section worth of lessons and then just keep them stored in their file folder so that they can quickly just access them. But writing out the problems and then having them printed out is a very quick and efficient way to read that problem. But it also allows you to highlight the facts as your students identify them. And then the neat thing is you can take those facts that they've identified, cut them out, and then just post them right on the solve poster. So it alleviates you having to rewrite everything out again. But what I really like about doing it that way is it allows students to see that the facts that we're pulling and are using on our solve poster process, they're coming right from the problem and they're directly connected to that solve poster process that we can use to solve problems in our everyday life. So it's that really great connection between the problem and the solve poster steps. So that's one way that you can write out the problem ahead of time and have it ready to go. You can use concrete objects on this using this method as well. It's just you might not have as much space if you were to use sentence strips. So sentence strips I did show within my presentation, but I do want to show it in a demonstration here just so you can see what that might look like. So I rewrote the problem on my sentence strips to say, Mr. Brandt works at the pet store. He scanned cat food. The customer gave 5 $1 bills and 3 $1 bills. What is the total amount? Now, to support my students in identifying the facts and the action, I can go through and support with the pictures and the objects that I have already kind of prepared here. So Mr. Brandt works at the pet store. So I'm using my image from the problem solving library, my poster card from my card content or my poster card set. He scanned cat food. The customer gave 5 $1 bills. So I can show what that looks like. 1, 2, 3, 4, 5, and 3 $1 bills. 1, 2, 3. I need to know what is the total amount. So now from here, as I show my solve poster steps to my students and I ask them, okay, here's our problem. What is our fact? What is something that we know? I might have a student who grabs at the can of cat food. And I can say, you're right. Mr. Brandt scanned a can of cat food. So I'm going to put that in our fact because that is something we know. What's something else we know? A student might say, well, the customer gave them 5 $1 bills and 3 $1 bills. You're right. What do we need to know though? What else do we need to know? Well, we need to know what the total amount is. So I can take the pick symbol for total and I can put that on my solve poster. So now I have my facts. They're all tangible and they're all easily visual for my students on my solve poster here. So now moving on to the second step, which is the action. This is where I can use my action cards that are displayed already in my pocket chart. As a general practice, I do recommend keeping the 3 action cards that are called out in every lesson stored and located in your pocket chart so that at any time during a lesson, you can always demonstrate, model, or have these provided as a choice for students to engage with the materials. So I can ask my students, all right, well, we know our facts are the customer gave 5 $1 bills and 3 $1 bills, and we need to know the total. And remember, total is the whole amount. So how can I find the whole amount? Do we want to add? Do we want to count? Or do we want to count on? If needed, I can take this opportunity to demonstrate each of these action words. So if I know that I might need to demonstrate what the word count means, I might use the dollar bills right from my facts to count them out and demonstrate what counting means with the dollar bills. Or I might demonstrate with the dollar bills what it means to count on. So that provides that support for students when they go to make their choice. So after I provide a demonstration as needed, I will then take the action that's selected and tape it right onto the solve poster so that my students can see that these actions are tied to that solve poster process and the problem that we're solving. The next step is estimating. Estimating in and of itself is an extremely abstract skill, regardless of your age or the classroom that you're teaching. To support students in making a reasonable estimate and learning what it means to make a reasonable estimate, I do have some tips that you might want to begin implementing when coming to this step on the solve poster. My first would be to create a benchmark for your students. So here I have a 10 frame box that came in your manipulative kit, and I have filled the 10 frame box with 10 connecting cubes plus an additional single one. So I'm going to take that additional single one out so that I can provide a benchmark of a set of 1 and a set of 10. So from here, I can go back to our facts and say, all right, well, we know that the customer gave Mr. Brandt a set of 5 $1 bills and a set of 3 $1 bills. What do I think the solution will look like? Will it look like 1 or will it look like 10? If you needed to replace these cubes for the actual dollar bills to make it that direct matching, you could certainly do so as well. But we're just really wanting to get our students to think about, what do I think my solution will look like? So from here, whatever the student chooses, if they choose that set of 10, I can take that estimate and then attach it or fasten it right to the solve poster step so that it can be used as that conversation piece at the end of our solve poster process to talk about, did we make a reasonable estimate? If my student chooses 1, absolutely attach it to your solve poster. And again, have that meaningful conversation. So that's one way that you can provide an estimate for a benchmark or for an estimate for an amount. You can increase these benchmarks to have a set of 10 compared to a set of 20, a set of 10 compared to a set of 50 to adjust with the amounts that you're using, whatever it might need to be for your particular problem that you're solving. Another really great tool that you can use when providing estimates is by using a filled stacked number line. So this stacked number line is filled with all of the amounts so that students can easily see the amounts that are represented by the numerals. From here, I can ask my students, all right, well, we know that the customer gave Mr. Brandt a set of 5 and a set of 3 $1 bills. What do I think the amount might be? What do I think the total will be? I can provide this all laid out for my student, or if I needed to provide 3 different choices for my student, I could certainly take off those choices and provide them for my student as needed. Once my student makes that choice, so I could say, all right, do I think it will look like a set of 1, a set of 5, or a set of 9? Once my student makes that choice, I can now take that amount and place it right on my solve poster. I like doing this with the stacked number line, as it allows me to now have that amount shown. And then at the end of the solve poster process, I can break this rod apart and then line up the dollar bills 1 to 1. And we can have that direct conversation about, okay, was our estimate reasonable? So those are just some tips to support you with estimating. When it comes to predicting, if you need to provide choices with other examples, so like a card, and then in this case, like a set of 9, what do I predict the solution might look like? Will it look like a butterfly, or will it look like a set of 9? You can still provide choices as well. Same rules apply. You would just place whatever they predicted on that solve poster and then compare it back to your solution to say, okay, how could we have adjusted our estimate or our prediction? The next step on the solve poster is your tool and strategy step. So for the tool and strategy, this is where before you go ahead and demonstrate a selected strategy, you do want to make sure that you model and demonstrate each strategy so that students have that opportunity to see how you as an experienced math learner would solve this problem with both strategies, and how you would then think through, well, what tool makes the most sense for you? Now, as we talked about during our presentation, there are going to be certain strategies that are more concrete. For some students, you might decide to implement the more concrete strategy to provide them with that model or that additional modeling opportunity. If some of your students need adaptations with those purple words, like in this case here, for students to access the math line, one of the adaptations in the Action Dictionary is to place manipulatives, or in this case, money cards, to the top of the math line tabs. If this was going to be a successful adaptation for my students, I would want to make sure to demonstrate that for my students so that they get the benefit of seeing that adaptation in action again. So here I could show my students what it means to count dollar bills using a math line. So I could show my students how I would solve the problem by counting a set of 5 and then a set of 3 on this math line tab to find my solution. The last step on the solve poster is the solution. I always tell teachers that it's really important that we spend a little bit of time on this step in first really modeling for students, thinking through how you got your solution, and then going back to your estimate to say, all right, well, we estimated that our solution looked like 9. Is that indeed what our solution was? Our estimate reasonable? So I can show my set of $8 here. Was that a reasonable solution, or was that a reasonable estimate? And we can have that conversation about, again, reasonable estimates or predictions. So when you go through the solution, make sure that you model what you're thinking. I added 5 plus 3 and got a total of $8. I estimated that my solution would be 9. I can see that my estimate, if I line up my cubes 1 to 1, I can see that my estimate was really close. So that was a reasonable estimate. So those were just some tips and demonstrations to get you started along that ownership path when beginning to problem solve within the equals math lesson. It is important to know that you have a variety of materials already at your fingertips within your equals math kit. So know that you have your lesson pick symbols that you most likely have already printed out for the lesson that you're teaching. Use those lesson pick symbols to support your problem as with pick symbols or as needed for your students. Remember, you have your problem solving images. Those are found within your members only content folder. If you feel like it would be helpful for your students to provide that visual representation or even those concrete representations that are labeled with those pick symbols, make sure you locate those. Within your card box, you have your poster, vocabulary, action, and content cards. Those all can be used as well to support the facts, actions, and units within your problem. Concrete connections are a great way to support students understanding the vocabulary words that are present within the problem. So if you have students who might be struggling with the vocabulary word meaning, use the concrete connection that you made in the lesson to reinforce that vocabulary word meaning. The manipulatives are a great tool to use to provide that concrete representation of the facts, as well as providing that demonstration opportunity. You can even use the manipulatives, as you saw today, to provide estimation benchmarks as needed. Your tray is a terrific tool that you can use as well to provide or contain the solve poster. If you do decide to cut it out, you can place the solve poster steps within the tray along with the manipulatives or pick symbols that you're deciding to use. Materials that are not included in the kit that might be helpful to you as you begin the problem solving activities are sentence strips, a display board, student photos, and environmental examples. I have put together all of the tips that I described during my demonstration on a handout. So there is the Solve Poster Training Tip handout. It is found within your members only content within your training handouts folder. Know that not everything is a trial. You might feel that you're giving away the answer, and that is okay. You might feel that you're repeating yourself quite a bit as you start talking about the action words and the strategies. That would be absolutely expected. Those action words are tied to the strategies. So you will find a little bit of repetition there, but it's important to see and for students to see that those actions can be used in a strategy with a tool. So know that not everything is a trial. You're not giving away the answer, and you're really supporting students in thinking through how they are problem solving or how they are tackling a problem when they are faced with it. Exploration and observation are important. So as you begin these problem solving activities, know that your model, especially during Think About It, is critical. So take that time, be elaborate with your demonstration, really show your students what you're thinking so that they get that opportunity to see how an experienced math learner works through a problem with the tools and the same action cards that they will be using. As you first start the problem solving activities, you might find that choices are really going to be your go-to support to work through each step, and that is absolutely okay. So provide choices as that first step for learning and language as you go through these solve poster steps. And again, if you're looking for those tips that we went through for each step that I showed during the demonstration, you can absolutely find that within the members only content within your training handout folder. We've come to the end of our Solve Poster training today. If you have any questions, you can always reach out to our customer service team at customerservice@ablenetinc.com. I thank you for your time today. My biggest piece of advice is to go slow when starting the problem-solving activities and have fun with them. Thank you.